Good afternoon, everyone. My name is Tatiana Jenkins, and today I'll be presenting on CBIR framework in regards to image processing, better known as content-based image retrieval. So to briefly go over our table of contents, introduction will be done today, a little bit of background research presented to you, the methodology of following its results, the CBIR framework implementation further discussed, the CBIR framework pros or advantages, the CBIR framework cons, disadvantages, the conclusion, a little bit of future research, along with the references that will be listed. Please stay tuned as well for the demonstration of this actual framework and how it can benefit you. So what is this? Digital image processing is the process of an image being done through a digital computer using different algorithms. Image processing can be a very tedious process when trying to implement things as detailed as this project was for CBIR framework, but utilizing different data sets, algorithms, and coding calculations will all help the success of implementing this actual framework. Mastering content-based image retrieval requires a system to process information that the image data is being tested for and contains, and then creates an abstract of this content for its visual attributes. So feature extraction. CBIR can be used for so many different applications and entities like crime prevention, digital libraries, and even historical research. This framework can overcome numerous issues when it comes to visual extraction models and can have as its base of visual analysis of contents that are part of the actual query image as shown to the left here. Our query image being on the right and what is being extracted and going through its process being on the left. So a little background research on how this can be done. Image processing is utilized in a plethora of fields, as stated already, outside of computer science. This process is used to manipulate data to make it suitable to process further for any adjustments that might need to be made to the actual data at hand. So having a powerful computer, having a large memory space on your device, and even having graphic software can all help the experience when utilizing this process to make it even better. In this actual research, Kanata-san went over conducting his research on medical image processing of actual tumor, as you can see on the left. Utilizing CBIR framework in this instance allowed for a bag of features to be introduced, allowing these image features to be used to gauge similarities between the images in the data set and include global image features such as the color, the texture, and shape to be compared. Image features can also be local image features such as speeded up robust features, which we might know as SERP, histogram of gradients, which we learned, or locating binary patterns. These features can be used to customize and fit any application that is being used. The image on the left shows, as stated, an implication of this brain scan, utilizing a query image being on the farther left-hand side, and then seeing what was extracted and being pulled from the data set to compare to what Kanata-san was researching on the right. So how does this work? When implementing this framework, it is important that you are using a machine that can hold the data that is being collected and actually retrieved. So step one will be to create an actual database, which will be our small data set in our project. This image database can hold up to however many images you may need, which is an advantage of using the CBIR framework system. Step two will be to extract features in the database, so depicting what the key focus will be in the images, like their pixels, the color levels, and things of that nature. Step three will be to save the features that are actually extracted. Four will then be to sort them just to keep the database a little bit more organized. Step 5 will be to calculate the distance. Here we use Euclidean distance between the images to calculate and differentiate them to distinguish them prior to us getting an actual visual image out of our system of the differences. Step 6 will then be compute and extract these features and begin to sort them based upon the distance that was calculated in the previous step. Then we'll be prompted to actually select a query image to run all this data and everything that we implement, so our model image can be compared to contrast. So our query image could be a prime example here on our right hand side of this young lady that can be selected from our database. Then the features will be extracted from the query image utilizing the CBIR framework, and the results will show. So let's see what we actually utilize in our project. So the top photos here are a part of our small data set that were selected. We were implementing about 20 images to be shown in ascending order. So as these photos go down the row, it gets further away from the query image, showing the distances and the differences from the image in the data set than what was selected. So this image below is actually just a follow-up of the results when utilizing the methodology mentioned in the previous slides when utilizing images and even words. This framework is used to find images closest to the image selected from the database, which is our query image as stated before. And as you can see, for the use of selecting the red balloon, it pulled everything that was closest to what the red balloon is. Is it the same texture as the red balloon? No, but that is what's tested, the shapes, the colors, the pixels, and even the textures as stated. Even when utilizing this framework for things like words, it'll pull everything that's closest to what a tiger may look like from what the database may know. So that is what's shown here. Implemented even for possible sketches, it may not be the exact sketch, but the system knows what a sketch is, so it'll pull everything that is closest to what the query-based image is, which is a sketch. So, a little bit of advantages of this particular framework, content-based image retrieval. When utilizing the system, it is the most practical framework when indexing and retrieving a large amount of images. So it is known for how much it can actually store and what it can retrieve, which is the differences in colors, textures, and shape, and even the spatials of these items are actually retrieved. It actually requires less time to complete the process and comparing the items in the framework, which allows your computer to actually run a little bit smoother and faster when trying to implement this framework for your database. The similarities of images are based upon the distance of features, so the Euclidean distance that was calculated. In the image on the left, the first image is actually our query image. Then it is ranked based upon which image relates most to the query image. So the farther it gets, the more differences you see. So this is a very clear image that we see here. The pixels start to change along with the colorways beginning to change, which is what our system is supposed to do, allowing you to see the differences of the image database. So a little bit of cons of this framework. Low-level features are more difficult to extract in this framework and interpret semantically during image context compared to other frameworks. So the semantic gap between low and high-level images can cause for features to kind of be hard to distinguish from the query image. This cannot be used. So this framework cannot be used for just any user. You have to completely select a query image in order for the data to run properly because you're ultimately comparing it to something. So this is a prime example on our left-hand side. So in this image on the left, the middle image B was actually brightened from its original state, which is our query image, which kind of set the features to be a little bit different when it is being measured, and it's throwing off what the image will calculate when calculating the Euclidean distance. So B ended up being closer to C because if we are technical, it's kind of distorted, being that it has been altered. Part of the problem is that representing an image by simple features usually results in a loss of information. So different pictures may map onto the same data set that it shouldn't. So B is mapping onto the same data set as C when it truthfully shouldn't, just because it was altered in simple terms. So to conclude, CBIR framework can be a very tedious process if things are not coded properly, but it is very informative when you're visually looking at it. The hardships of this framework can easily be avoided if the proper machine is being used and the right data set is selected. So having the best images possible to differentiate from instead of running into a semantic gap issue. Not running the system properly and not having all the data needed could have a tremendous effect on utilizing this framework, being that you can't really compare and contrast anything if steps are missed. So no steps can be missed. Emphasis on no steps can be missed. So content-based image retrieval has been proposed in the future to benefit not only management of increasingly large image collections, but also to aid clinical care, biomedical research, and education, as we saw in our background research when utilizing this in the medical field. This makes this framework important to go past simple projects. It is diverse when it comes to extracting images, data collection, and even its time complexity, but it puts an advantage over other frameworks which provides it a future to continue to expand. So comparing it to like KBIR, CBIR framework has a little bit more of an advantage when it comes to its time complexity. It is recommended that this framework implement some type of loophole in order to tie together that semantic gap, which is truthfully its only drawback when doing proper research. That is the only drawback that it has, being that if the image quality isn't good enough to be read, it'll throw the image data set off, not pulling it closer to its query image, which it might be actually closest to. Here are the references that were utilized. Well, I hope you enjoyed this presentation, but I'd love for you to stay to see the TSimone & Co. CBIR luxury framework software that will be available for you to purchase today. Let's go ahead and get to our drive here. This is our basis of the software, being our MATLAB. Here we have the TSimone & Co. software framework to show the greatness that you can receive today for just $25 a month to run your business smoothly, to process your data and logos, to see which may be a best fit for your company in this season. So the first thing you will need to do is simply to stay organized by creating folders for everything you are trying to do. So here we have our final project folder. Let's open that up. In this folder we have, which is our base folder, we have our source code, which is a subfolder, and our data folder. In this data folder, you will have all the images that you will import, so your logos and different marketing items that you would like to implement visually into this folder, holding right now up to 100 images. Let's go back, and here we have our source code. Let's just open one of these up to go ahead and get started. Now let's work. We will first generate our 6-bit color code, which will allocate different pixels in our imagery, and this indicates basically what we're looking for, which will create a histogram if you would like, just to see the intensity levels in the imagery and how it'll look on your maybe your website, different items you may place your logo on. This will generate that for you. But the most important part that we need to create is our database. So creating our database allows for things to be imported, which is our data, our logos, our marketing items, and then to be analyzed in order to extract these different features and the ultimate goal that we're looking for with the look of what your marketing items may be on what it will be put on. Next, which is key, is just calculating the Euclidean distance, which is the formula used here, between the images in our data set in order to sort them. So instead of your marketing team going through thousands and hundreds of images, which this framework can hold if you would like to purchase today, it'll just narrow it down for you, making it easier to visually see and read. Now let's get to the fun stuff. The CBIR framework, the luxury of this item. This framework shown is combining all the key components previously shown. This will give our system a chance to utilize the data that has been imported and pulled, all using extraction mechanisms, and allow us to select the image we may like and compare them to other potential images. So for right now, here we'll just set it to 20. This line right here sets our goal to 20. But first, you will need to run your database. Let's go ahead and pull everything. Let's make sure this is clear. Now let's run it. Make sure you're always in the proper folder when running it. So if you're going to run the coding implementation, go ahead and stay in that source code portion. We run it. We created our database here. Okay, perfect. Let's get to our fun stuff, our framework, so we can see what's going on with our marketing items. Be sure you're in your data folder. Let's go ahead and import one of these. Let's import 170. Let's open it up and see what it looks like. What luxury is coming out of this thing? Boom. Here we have it. You selected your query image here. And the rest, which is being compared to this query image to what may fit best and look best for your company in this moment, is being compared. So we're putting this in ascending order. You might not like the query image. You might like something down here. So it's giving you a visual to see, okay, I might not like this one, but this one may fit best for what we're putting it on. Let's try another one. Let's run it again. Let's make sure we're getting our data. We're going to import. Let's try 1312. Let's open that thing up. Boom. Lucky. Let's try it again. Isn't this just great? This might be our lucky one here. So if you like this today and you think this is a great option for you, feel free to contact me at TSimone & Co. to purchase. Again, that is $25 a month. Thank you.